Hello, welcome to my channel. In this video, we are going to derive the S parameters for a transmission line. So suppose you have a transmission line, the ideal transmission line, and the transmission lines look like this, and yes, the in-output port. So the output port is port 2, the input port is port 1. And we can say the position right at the port 2 is where z is equal to 0. And at port 1, we just go backward. For a length of minus L, so that's why we say that z at this point at port 1 is minus L. So we are ready now. And V, which is the voltage, the voltage at any point of the transmission line can be summarized in this equation. And if we substitute now at port 2, where z is equal to 0, then we have V2 is equal to z equal to 0. Yeah, according to this equation, we will get V plus minus. And if you remember what we have done in the previous video, we normally, under this condition, we can say, and then port 2, and then, yeah, so we can simply summarize this. And this one is equal to S22. At port 1, where Z is equal to minus L, we have V1 equals to V minus L, and using our we can write this equation as, yeah, we substitute minus L into this equation, then we get this. So let's say this is equation 1, and let's say this is equation 2 or whatever, yeah. And equation 2 can be further summarized as let's say we do this as 1, 1, yeah. Now we are going to assume the transmission line operates under a matched conditions. In this case, under a matched condition, S11 and S22 should be 0. So we can simply rewrite equation 1 and 2. One and two. One, we have, and two, and if we disregard this term, we get so let's say this is equation 4 and this is equation 5. Now we are going to use the same method as we did for other similar questions. First, we need to use the concept at part 1 and part 2. We know that under this condition, I'll pull it down a little bit. When port 2 is terminated with a matched load, there should be no excitation at port 2, and we can safely assume that V2 path, this means the incident wave into port 2 is 0. And also we need to be clear that at port 1, under a fully matched condition, there should be no refraction. In this case, V1 minus should be equal to 0. So this is a very important condition that we have to use. So let's continue. Let's continue. We have already known that V2 plus is 0. And we also know that V1 minus is 0 because we are dealing with a fully matched condition. There should be no refraction. If we substitute this condition to equation 4 and 5, if this is the case, then at port 2, we know that whatever voltage we measure at port 2 should be equal to V2 plus V2 minus. But under this condition, as I said, the incident wave at port 2 is 0. So this term is 0. So we can say V2 minus is equal to V2. And similarly, in port 1, we know that V1 is equal to V1 plus V1 minus. And we have already known that the refractive rate at port 1 is 0. So 0, and as a result, we can say, so now we are going to substitute this condition back to equation 4 and 5. Let's see what happened. So in equation 4 and 5, if we divide equation 4 and 5, divide equation 4 by equation 5. So equation 4 divided by equation 5. And let's see what happened. Divided by equation 5. So V2 divided by V1 is equals to minus. We have got this interesting, yeah. According to here, yeah, equation 4 divided by equation 5, it is like this. And now we are going to substitute this value back to this equation, and you will be surprised. V2 is actually equal to V2 minus. V1 is actually equal to V1 plus. So this means V2 minus is equal to V1 plus. So now it's now getting very clear now. If V2 minus is equal to V1 plus S21 and then S22 V1, sorry. So this is the equation from the S matrix. The S matrix. You know that, right? V1, V2 minus S11, S22, S12, S21. Yeah, this equation came from here. Yeah, it came from here. And if we compare this equation, say this is 6 and this is 7. And if we do a comparison between 6 and 7, you know that S21 is equal to this value. And because transmission line is a passive network, in a passive network, S21 is always equal to S12. And in this case, yeah, the reason is transmission line is a passive network. When the transmission line is passive, then it should be reciprocal. And if it is reciprocal, then S12 and S21 will be the same. And according to our previous result, S21 is actually equal to e to the power minus gamma L, where gamma is alpha plus J beta. So I have actually taken care taken the attenuation into consideration as well. So with this in mind, we shouldn't have any issue, right? S11 and S22 is 0. So the S parameter for a transmission line is going to be 0, 0. So I hope this is clear. If you have any question, please leave your question to the comment section of the video. Thank you. Bye-bye.